Good morning, everybody. Thank you for coming to this next BERS event. Today we have a panelist of folks from a variety of different departments, from math to physics to statistics, to ask and discuss questions concerning careers in those departments as a theoretical biologist. I'm just going to share my screen here for a second. So this is just a quick reminder about today's event and upcoming events. So our next event will be Tuesday, February 13th. And it's the first in a series of events on technology. And this one in particular is on MS Prime. I want to say thank you for everybody that has contributed to past and will contribute to future events. And thank you to BERS and to our other support, such as Stanford. I want to stop sharing and just jump right in because I think we have a lot of things to discuss today. So I want to start by introducing our panelists. Our first panelist is Ben Ashby from SFU Math, and Carolyn Colline, also from SFU Math. If you have any questions about interactions within departments, now we have two people from the same department to discuss those. Laura Kubutko from Ohio State University, and Daniel Weissman from Emory. So thank you guys for coming. Laura is from statistics and Daniel is from physics. So a large range of representation here. How today will work is I'll start by going over four specific questions that we have for our panelists. But as I go through these different questions, please send questions that you have for the panelists in the chat. And then we will go through audience questions in hopefully a semi-organized manner. All right. Any questions before we begin? All right. I'm just going to go in alphabetical order. So in the order that I introduced you guys, the first general question we have for our panelists is just to give a brief description of your career path and how you ended up in the department that you ended up in. Ben, do you want to get us started?
Sure, thanks, Ailene. So I'll try and be brief. I started off with a mathematics background in my undergraduate days at the University of Warwick in the UK. So the system's a little bit different there to North America, in that you're specialized pretty much from day one in one particular area. So I was a mathematics undergraduate. I got interested in mathematical biology in sort of my second and third years in particular. And then I made a transition to do straight into a PhD at Oxford in the zoology department, which was quite a shift because I hadn't actually done any formal biology since I was 16 at that point. So jumping straight into a zoology department was definitely an interesting transition from being in a math background. I then went to the University of Exeter to also to a biology department to do my postdoc. And I spent some time at UC Berkeley as well in their integrative biology department. So that most of my postgraduate training was in biology departments. I then got a faculty job in the UK at the University of Bath in their mathematical sciences department, so switching back to math. That was in 2016. And then I moved to SFU Math in spring of 2022. So just coming up to a couple of years here. So I've definitely done the switch back and forth between math and biology environments. Does that answer your question enough, Ailene?
Thank you so much. And so now we'll see actually a lot of parallels in Carolyn's path. But so Carolyn, if you wouldn't mind sharing.
Sure. Yeah, I started actually here in Vancouver at UBC, and I really wanted to do physics and learn about the deep mysteries of the universe and large scale physics and kind of relativity and that kind of thing. I then did a master's degree that took a really different turn in environmental studies at a really innovative master's program at York University in Toronto. And then I got interested in complex systems and system dynamics there, and I got interested in the kind of quantum classical correspondence. And I thought if there was a great time in life to learn about the foundations of quantum theory, the PhD was probably a good time to do that. So I did a PhD in applied math at Waterloo, and I looked at the foundations of quantum theory in this very sort of obscure field of quantum theory, about that's really it's really foundational and philosophical, and it's absolutely not about, oh, we're going to get new data to resolve these questions. They're sort of more philosophical questions. And then it was after that, as a postdoc, that I got interested in modeling in biology, and I went to work with Michael Mackey at McGill University, and then after that I went to a postdoc at the Harvard School of Public Health. And that was really where I got interested in infectious disease and evolution, and using modeling and math, but also some of those interests in system dynamics and complex systems, to think about infectious diseases and how they spread. And I think it kind of connects in that you have these really small scale phenomena. Viruses and bacteria are obviously very small, they're tiny organisms, but their impacts on hosts and between hosts and on their ecology is at really large scales. From there, I got my first faculty job at the University of Bristol in the UK in an engineering mathematics department. And that was really nice, kind of a dynamic, vibrant group with working on a large range of applications. From there, I went to Imperial College, where I had a faculty position for about 7 years. And then I moved back to SFU with the Canada 150 Research Chair Scheme in 2018.
Wow, so I think one thing that is really impressive is just the number of different types of departments we've already heard about in your two stories. So thank you. Laura?
Yeah, thank you. So I actually started my bachelor's degree as a biology undergraduate with no real thought of doing any sort of mathematics or statistics at all. I went to a really tiny college in Ohio called Hiram College, that had a field station and therefore opportunities to do actual field work. So I was lucky to get involved with some undergraduate research there. And through that process, realized that I really liked analyzing data. So I'd kind of been taking math classes on the side because I thought they were fun, and then sort of saw a path to use something that I found fun to analyze data that biologists were collecting. So after so I ended up adding a math major sort of toward the end of my undergrad career, and graduated with both majors. And then I went to graduate school at Ohio State in biostatistics, with the intention of doing theoretical ecology, which is not at all what I ended up doing. So after taking courses for a couple of years, I met my advisor, who was working in evolutionary biology, and then sort of got hooked on that. So I finished up my PhD in biostatistics, and then my first faculty position was at the University of New Mexico, where I was in a mathematics and statistics department. And I was there for 7 years before I came back to Ohio State University. And here I'm jointly appointed to the statistics department and to the Department of Evolution, Ecology, and Organismal Biology. And I've continued my interest in evolutionary biology from there.
Thank you. At some point, I'm going to I would love to hear your thoughts on that joint appointment. So I'll revisit that in a little bit. Thank you, Daniel.
Okay, so like Carolyn, I started out in physics, in undergrad, physics and math actually, but unlike her, I was not into it at all. I was just kind of doing it because I was good at that stuff, and I thought that's what you did. And I even started grad school thinking I was going to do string theory, but I quickly realized I was even less interested in that, and so I switched to evolution. And then when it was time to do a postdoc, I was like, I applied to both physics and biology groups, and I was like, no, I'm gonna be a biologist. I'm switching to biology. So I did a postdoc with Nick Barton, a population geneticist. And then I was like, well, maybe I'll try something. And I did a brief fellowship at a computer science institute at Berkeley, which was a fiasco, but very entertaining in a lot of ways. And then I did a short postdoc with a biophysicist who was doing basically evolution. And you know, so I thought I was a total biologist, but when I applied for faculty jobs, I found out that people still saw me as a physicist, and you know, I got an offer here from a physics department, and I went and asked them, I'm like, hey, you know, I'm going to be publishing biology journals. Is that okay? And they're like, yeah, fine. So it's like, okay, I'll do it.
Wonderful, thank you so much. So as I noted, there's a huge range of different departments represented here, which is really, really cool. So what have you guys found to be particular advantages or challenges to these different departments, namely in your current careers, but then also like throughout this career path? Is there anybody in particular that would want to start, or we can go back in order? Okay, go ahead, Ben. And if other people have thoughts as Ben talks, feel free to raise your hand and I'll interject.
Okay, yeah. So in terms of, I'll probably focus a little bit more on challenges, maybe. So I would say being interdisciplinary is a double-edged sword in the sense that you have the opportunity as a theoretical biologist, you can collaborate with theoreticians, you can be seen as a mathematician, you can potentially be seen and collaborate with biologists, and you can bridge that gap, which can be great, but also can be very challenging because sometimes those camps, the biology camp, maybe in the math camp, might not see you as one of their own. And that can be especially challenging. I'll give the example, say, in a maths department, is if you, Daniel just mentioned about publishing in biology journals. Well, they might not know any of those journals. And that's a particular problem, say, in the UK, where there's the research excellence framework that happens every few years. And that involves a big exercise of essentially judging the quality of your research output. And if your research output is being judged by the mathematicians, but is being published in biology journals, that can present some problems. That's a particular UK problem, but I think more generally about being viewed as whether you are a mathematician or whether you are a biologist. Can sometimes be a bit of a problem. I'd say that can also come through at the funding level as well. Everyone says they want to have interdisciplinary research, but then sometimes won't fund it because they say, well, it's not quite our remit or it's not quite their remit. I think the other thing I would probably say in terms of I guess just the general feeling of belonging within those departments perhaps is and whether your research really comes across to your colleagues as being related to the kinds of things that they would believe in. So again, thinking of being in a maths department in particular, what qualifies as new math? It doesn't always, if you're, say, using a system of ODEs to model a population, is that new math, or are you just applying existing mathematical ideas? And that sometimes has come across before in the past as being like, well, are you doing real math in a math department? Yeah, I'll stop there. But if anyone else wants to jump in, they might have thoughts on that or other things.
I mean, I think this is something that is much tougher for math and bio than for physics and bio, because physics and bio are both sciences, and so, if I'm solving problems about the natural world, it's much easier to sell to physicists as, this is something that we should call physics. I feel like when I talk to people in math bars, there's much more of a tension of like, am I I've got some model of biology. Is it that, biology motivated the model, but now I really care about the model and I want to do mathematics on the model? Or is it, no, I don't care about the model. I'm really trying to understand the biology, and you kind of, so different people want you to say different things there. Whereas for me, it's like, no one wants me to care about the model. Everyone wants me to care about the system it's describing.
Yeah, that's actually a really good point. I've definitely encountered, I'd say, maybe two types of mathematical biologists or theoretical biologists: those who are interested in the underlying math and will only work on a biological problem if the actual math that comes out of it is interesting itself, as opposed to people, and I probably place myself in the second camp here, who want to answer interesting biological questions using mathematical modeling. So yeah, I would agree that's definitely a challenge there. One other thing actually I forgot to mention, maybe on the more sort of like career and sort of professional development side of things, in terms of your career trajectory is like expectations in those departments as well. Like one of the advantages perhaps I've talked about disadvantages. One of the advantages maybe of being in a maths department is, say, expectations of funding are much lower generally than they would be in a biology department, because you're being compared to your peers who would maybe have labs to run, and so they're bringing in these big biology grants. In a maths department, typically expectations around funding are lower, so that can offset some of your, you could potentially be viewed as being very successful from a research funding perspective if you're collaborating with biologists and you're on these big grants and you bring in lots of money.
Carolyn, I think you had something you wanted to add.
Yeah, I want to pick up on that because I think it's really important. It's one of the things I noted down, with challenges of interdisciplinary work. And I think, I want to acknowledge that there is a space that is like kind of analogous to the uncanny valley, which you've probably heard of. What I think of as kind of the unuseful valley that interdisciplinary work can fall into. And I think we need to be a bit on guard and aware of, we can fall into work that is not new math and not new biology. We need to do new science. I want to do new science, and we can use modeling as a tool for that. And I think one of the exciting things about modern quantitative biology is that we do have genuinely the need for new mathematical models and tools and new applied probability. And one of the things that I hit upon when I was at Imperial was tree metrics. And that's something where, like, okay, mathematicians will say, yeah, all right, like that's something that I can see is a mathematical question, how those things work and what are they, or new things in coalescent theory or new types of models. I do think there's there is the risk of falling into, here's my new set of ODEs and this is what it does in my computer, and sometimes not thinking too carefully about what are the standards that we need to think about to ensure that that model is helping us do good quality scientific reasoning, rather than providing a mathematical toy that we can play with, that we can say, oh, like I like how these equations go. And a lot of people who went into math departments actually like math, and that's completely relatable. And I have sympathy for that. And I think that the idea that a math department might ask its potential hires what they are doing that has mathematical depth is relatable. And I think we all have kind of a spectrum where probably none of us would think, okay, so you bring me your data frame and I'm going to run logistic regression for you, and this is my new science. We're all doing more, probably more substantial new mathematics than that. Maybe some people would say, oh, you made like another linear set of ODEs and you're going to solve it. And this is like, that's analogous to like, I'm going to run logistic regression for you. So I think we'd have to think about that thoughtfully and carefully. And I do think it's one of the main challenges in interdisciplinary work, that we are in disciplinary departments and we have to use our own judgment to think about what is good science. We don't have major conferences of the gap between field A and field B, where you can get a prize in being the lead speaker in the gap between field A and field B. So that's another career related thing. So I think there are challenges, but I also think it's a tremendously satisfying area that has incredible scope for creativity. I think there's also this is like, and then I'll stop, but I wanted to get at the notion that I think is there in math and maybe also in physics departments, that the more pure work is harder and it's done by smarter people. And we had at one point someone say, oh, well, if a student came and they were really great, I'd give them a theorem proving problem. But if they were a little weaker, like I'd just give them an applied problem. And I was like, no, like this is a terrible framing that, that not that there's never been truth in it. Of course, like there's some problems, that you can just like incrementally make progress, and other problems you don't. And that can be true in both pure and applied work. But it hasn't always been my experience. I've definitely had trainees who are great at pure math and they've had great marks in their pure math courses, and they haven't achieved the kind of curiosity and judgment that I think is needed to do science. And I've become interested in, like, how does that scientific judgment, where does it come from? How do we nurture it? How do we build those judgment calls, those curiosities, those, oh, like, do we go down this path or that path? Or like, what are the next figures that will help us here? So I think those are some interesting themes.
Yeah, I was just going to jump in and to agree with everything that's been discussed so far, and also add about the funding, that it is an advantage if you're in, you know, perhaps a math or stat department to be in these biology grants. So if you have, like I do, a component of your appointment that's in biology, then you are criticized for not having big enough grants. I've had on the same day meeting with chairs of 2 departments for my annual reviews, and one told me, wow, you have so much funding, and the other told me you need to work on getting more funding, and it was all the same grants. So so to deal with things like that, what I tend to ask myself is, you know, what are my contributions to the statistics department that I'm in, and what are my contributions to my biology department? And I've tried to be really intentional with thinking through, you know, what parts of what I do contribute to each field, so that when I'm going through an evaluation process, or when someone's talking to me about this joint appointment and, you know, has questions, what do you contribute? I've thought about that ahead of time. So I think that is an important thing for people who are interdisciplinary to think about is, you know, what contributions are they making to the fields that they touch? Like, what would they, you know, say are the contributions? The other thing that I'll just quickly add is teaching. Most of us are teaching, and I find being an interdisciplinary researcher to be both a challenge and an advantage in teaching. So challenging because sometimes you know, you're supposed to teach a certain amount in a certain department, and you're trying to figure out, you know, what courses are most suited to you know, what your experience is. But it's a real opportunity as well. So for example, at OSU, I've been able to develop a course for undergraduates called Statistics for the Life Sciences, where we're teaching, you know, your first course in calculus-based statistics, but all of the examples come from biology. And it's such a big university that we have huge enrollment in that class, and we've done some things that are really different in that class than what students would encounter in a typical, you know, first semester calc-based stat class. So there are some real opportunities that you can do some innovative teaching as well, because you have this background that appeals to a broader group of students. So I will stop there.
Okay, so actually, one of the things I'd like to direct follow on this. One of the things I had written on my advantages is actually that I don't have to do innovative teaching. It's way easier to teach physics classes. Like I teach, like I can teach electricity and magnetism, right? Nothing was discovered in the last 100 years that I'm teaching, right? And there's beautiful textbooks that have been worked on. And then, you know, I see my colleagues who have to teach evolution, and every year it's like, you know, they have to rewrite their lectures. It's why I love working in evolution, but when I want to just like coast on a class, or, you know, not coast, but like, you know, take it easy on a class, I can do that. You know, sometimes I want to do something more, you know, invest more in a class, right? And actually then sometimes it's a little frustrating. I haven't really been able to teach a population biology class because, you know, there's not the demand for it in physics. But
So actually, quick follow-up for you, Daniel. Is there any biology that's too biological for a physics department in your view?
Like, to be hired or to teach a course, or?
Well, I don't know, to I guess be in a physics department.
I'm in an extremely unusual physics department that is half biophysics, and then among the biophysics has a lot of people who are really doing quantitative biology that would be, you know, totally, you know, at home in a biology department. I think there's very few physics departments that have people like me in them. Yeah. And actually, it was something I noticed that, like, wait, look who's here, right? We've got 2 people from the same department, right? So another special department, you know, and Laura's from OSU, which of course is huge in mathematical biology, right? Really committed to that. So we're you know, that there's certain special places that are more open to these kind of things. And many other places where you just, you know, there's no one on this call from there.
Ben, I think you had something you wanted to add.
Yeah, I guess to like just go back to a couple of points that made one that Karen said about the difficulty, the perception, I guess, of applied math and theoretical biology versus, say, pure math. That's definitely, again, something we've encountered, and I think the point you raised about like scientific curiosity is really important, and I think maybe there's a bit of snobbery sometimes that comes from, say, like the pure math side, potentially, as like, oh, this isn't real math, or that's just going to be easy. And a lot of people think that they say understand evolution, and they don't actually understand evolution. They have a very superficial understanding of the actual processes, things like, oh, this is good for the population, therefore that will evolve. That kind of thinking is quite common, and especially taking students on from, say, a math background, they think that they maybe understand it, but they don't really understand it at a deeper level. But like having that like understanding things conceptually and having that scientific curiosity, I think is a big part of the challenge, even if perhaps technically some of the math isn't as technically challenging as some of the other math might be in all cases. And then the other thing about the teaching, I find teaching life sciences students very rewarding, especially those that have a perception of math as being very, very difficult and not the kind of thing that they can do. Sometimes doing that interdisciplinary teaching can be sometimes more rewarding than, say, teaching mathematicians for me, because you get that kind of breakthrough moment where they think, oh, okay, I understand this thing, or I understand its relevance to something else that I'm studying in biology. And I think if you have that interdisciplinary research background, you can make those connections much better than maybe someone who doesn't have that interdisciplinary background.
I'm going to pause us there for a second, because I think we have touched on a large range of topics that we can delve into in more detail. But I want to make sure that people have a chance to get their questions answered. So this is just a reminder to the audience that if you have questions for our panelists, to submit them to the chat. And thank you for the few of you that have already done this. One of the themes that is popping up in the chat already is a focus on not just faculty positions, but your life as a PhD student and as a postdoc. So with that in mind, I want to move on to our last general question, which is, what is the theoretical biology community like at your institution, and how does it shape your research career? I should probably point to somebody. Does anybody in particular want to start? Well, given that we have two people from the same institution, maybe we'll serve as one of you. Carolyn, would you like to go first?
Sure, I can start. I mean, I guess my career is longer. I'm older. And so I'm going to answer that with reference to a number of different institutions that have shaped my research, because I didn't join SFU and go, okay, like now what am I doing? I'll do something else. Obviously, I brought a research program with me through my career and developed it through my career. I think in Bristol, the environment around being in a department where essentially everyone was an applied mathematician and bringing different tools and a really open-minded sense of, what is applied math, because it was very broad, and really wanting to do what I consider, I guess maybe somewhat pejoratively, to be genuine applied mathematics, where it's not just kind of pure mathematics done in areas of mathematics that have conventionally been applied, but really applying it. So I think that informed me and kind of maybe helped me to, switch directions from dynamical systems into more evolution and infectious disease and phylogenies. And then at Imperial, I was in the math department, but I collaborated closely with a world-famous Department of Infectious Disease Epidemiology, where they do a lot of phylogenetics and infectious disease evolution. So that, I think, was a great place to have access to. And I now wish I had made the journey across Hyde Park more often, but I had kids in the nursery at Imperial, and it was just like London logistics with little kids, and starting a new group was the challenge. And then I think coming here, SFU has been really supportive of all the pandemic work that I did, and I did a lot. And so that was really enabling to have colleagues who stepped up to have a teaching reduction from directing the CanMod network and other activities. So I think that also helped shape what I did. And, SFU really valuing the public engagement and policy engagement that I did helped shape the last few years for sure.
I guess if I'll focus a little bit more maybe on the like training, during your PhD postdoc days, perhaps pre-faculty. For me as a mathematician, going into biology departments felt like I was asking a lot of dumb questions because I didn't have the biology background. But I also felt like immersing yourself in a different field in that context was very good in terms of being able to broaden my horizons. I felt like one of the advantages of, say, being in a biology department is that, generally speaking, I think it's easier to go to a wide range of seminars and maybe understand what's going on, or at least a lot of what's going on, unless it gets too molecular, and then it's kind of a bit lost on me. But if in contrast, going and say like a math department, if you go to like a number theory seminar or an applied math seminar or probability seminar, very quickly you might struggle to go to these different areas and understand really what's going on. The things do tend to be a bit more separated. So something nice about being in a theoretical biology community is that you potentially have the opportunity to go to a broader range of seminars in the biological realm. In terms of the actual institutions I've been at, broadly things have been pretty supportive. I think the challenge of being that theoretician in a biology department is that maybe people don't really understand a lot of the theory, that tend to be very heavily empirically focused, at least in the ones that I've been in. So you can feel like a little bit of an outsider. Maybe people don't understand quite what you do or how you do things. But I would say most of the places I've been, they've had centers of mathematical biology, or there has been a group of mathematical biologists, and that has been very helpful. At SFU, we've recently grown in terms of the number of mathematical biologists that are here, me being one of them. And having a community of people that have shared interests is very valuable. I think if I was, say, the only mathematical biologist or theoretical biologist in a math department, I might find that quite challenging.
Laura, this is the point where I get to ask you those questions about being cross-appointed, because I think you probably have really unique perspectives on this.
Yeah, so I'll maybe say a little bit about, how I came to be cross-appointed at OSU. So my first faculty position was not a joint appointment. And so I, did have the start to my career involved being only in a single department, which was pretty valuable in terms of me kind of figuring out, who I was within the statistics community and what I wanted to work on and getting my research program going. When I came to OSU, I was part of a group of hires that were to be jointly appointed between the mathematics department, the statistics department, and the Department of Evolution and Ecology at OSU. So there's a bunch of us that have these sort of varying appointments. As one of the other panelists mentioned, OSU is a place where mathematical biology has been a big, well-represented research area. So I was sort of entering a community where there were a bunch of people working in that area. But having said that, mathematical biology is a really broad term. I mean, I don't do anything with ODEs and PDEs, for example, and a lot of the math bio group here at OSU does work in that kind of mathematical biology. So even within that community, I'm a little bit different than some of the other hires. But I think what you get from being in a community like that is appreciation for the fact that research can make contributions to multiple fields at the same time, and some sort of understanding that biology can drive interesting problems in mathematics and statistics. And so I have found it to be a really supportive community. And so, I think that, this joint appointment is great for me. I enjoy learning. I end up being on a lot of committees for PhD students that are in biology, and that helps me learn a lot about what problems they are working on, and hopefully I'm helpful in terms of the kinds of things that I work on and the advice I can give. But it's really been a great source of problems and understanding for me, and I've enjoyed the joint appointment a lot. So I will say, as I mentioned, my first job was solely in a mathematics and statistics department, and there were three distinct groups: the statistics faculty, the applied math faculty, and the pure math faculty. I think statistics and applied math were a little bit closer than either of us was to pure math in terms of sort of how we viewed what we do. But the three groups were about equal in size, and I was the only person who did anything having to do with genetics in that entire faculty of 30. And while that maybe sounds bad, and certainly that was the start of my career, and there were times I felt isolated, it was also pretty exciting because it was a department that wanted to, have someone who did those things. And so I think I felt valued by my colleagues. I also had the opportunity to get involved a lot with projects at the medical school there that were genetics based, and I was sort of the person that was doing that. And so while it was tough, it also provided some opportunities that I was able to take advantage of. So, it's hard in certain ways to be maybe the only one working in an interdisciplinary area, but there's also opportunity that comes with that. And if you are in a supportive environment, it can work out pretty well. So those are some quick thoughts about that.
Wonderful, thank you. Daniel, do you have anything to add from a physics perspective?
I did this. we've got a really great community here. We've got a special theoretical biology institute, and we've got our biological graduate programs are free floating from departments. So I'm a, absolutely full member of the Eco-Evo graduate department, an equal stand to someone in biology. Yeah. So it's a really special place that again, you got to find the right place to do it.
So one theme I kind of see coming through this is having a dedicated community is really important, and this intention of interdisciplinary researchers. So thank you everybody for
Actually, wait,
submitting.
can I say one thing?
Yes,
It's I feel kind of funny. I'm not actually interdisciplinary. I'm a population geneticist, right? I just happen to be a physicist who does it. So that's a bit of a weird thing, right?
Very good point that we don't have to own that word.
I don't know, but so one advantage is like I get funding from physics. People, Graham Coop can't get funding from physics. I can, is it fair? No, but I'll take advantage of it.
Thank you. Very good point. So thanks for everybody who has asked questions already from the audience, and for our panelists for answering some of those questions. But I still want to use those questions that you have answered as to build on some themes. So one theme that has been showing up in the questions is, and I think showed up earlier in your guys' responses, is this idea of belonging and perceptions in different departments. So John asked about this, and Aaron, and combined with the idea of maybe colleagues having misconceptions about what you do, or making incorrect assumptions about what you do. But it also can have a positive part. So, are there positive things to how you belong in your department? Anybody want to get us started?
I guess I could say that, a real positive is that students are really interested in genetics and genomics, and being able to teach some courses or just talk some about my research in a way that recognizes that students that may not have any background in biology, because we have a lot of international students who may not have had much biology at all in their background, but trying to teach in a way that sort of welcomes them in and says, that's okay, we can talk about the biology parts, and you maybe have something to contribute with your stat training. So I do think a positive is sort of, reaching out to people who, have been maybe scared or hesitant to enter the field because they don't feel that they have the background, and, welcoming them in when they're interested, and trying to help them learn some of this application area. So it's for me a really nice thing that sort of happens pretty regularly.
Thanks for getting us started on a positive note. Thank you. Does anybody want to add more to that? Well, we can come back and revisit it if we want to. But I think Kaleda had a really important question about time management. And I think this is a particular challenge when you're, sorry, Daniel, trying to do interdisciplinary work and maybe trying to do two things at the same time and have these competing pressures. And even beyond research, like reading the literature, how you devote time to that. So does anybody want to talk about time management throughout your career, or that's particular to our field?
I can kind of echo for the people who haven't read it in the chat a little bit of my response about that was some of the mistakes I maybe made is like trying to expand too quickly, say as a new PI, and take on lots of students, and then not maybe realizing as to how much work that was going to entail. I did receive a piece of good advice, which I passed on, which was that try to dedicate some time to yourself and not entirely to others. So having a few hours or half a day, or even a day if you can really manage it, where you don't have meetings, you don't especially have meetings with students, or you don't work on their manuscripts and things like that. You have like a dedicated project that is just for you, maybe for you with collaborators that are not students, especially earlier during your career, so that you keep up that research keep up your skills, I guess, in some ways, and don't just like switch to someone who's a manager and does lots of editorial stuff and things like that. That's pretty quite good for your sanity, I think, to make a bit of a separation, that you don't just give everything to your students and don't keep anything to yourself. Anyway, Carolyn, you.
Yeah, I replied in the chat to say similarly. And I wanted to add, I think it also builds empathy, and keeps you current with, how to code something or how hard it is to actually download those data and align those things and like do the error checking. And I think it helps us stay, or at least it helps me stay grounded in what are the challenges of actually doing and carrying out a project. I do feel sometimes with the group size I've had and with the pandemic work, that what can happen is that I want to have my own project that I really do, but it can only be an easy one executed poorly. And of course, this is not a great idea. And, maybe that's not the reality, but that can be sometimes how I perceive it, though. Oh, I wish I could do X, Y, Z and PDQ, but I can only do like this tiny thing. But despite that, I still think it's worth it to do that and have like my own thing that I'm trying to forward. And sometimes it goes slowly, but yeah, if you can set aside time, I think that's a really great idea.
Actually, I have a question for the other panelists. I mean, I feel a tension between like for my training mission, like how much am I trying to get like physicists interested in biology versus get more biologists interested in theory and quantitative work? Because I have to, it's two different. It's hard to do something that works for both audiences. Have you folks felt that? How have you navigated that?
I would say it would absolutely is a challenge. It's something that we've discussed a lot in terms of like, for say undergrad teaching, like should we be trying to encourage biology majors to think about doing math minors or even switching completely to doing math? I think from my limited experience is that there are lots of biologists who have chosen to do biology but are actually very mathematically capable, maybe don't realize that math biology is a thing. I mean, I didn't realize that math biology was a thing until my second year as being an undergraduate. And so I think there is a lot of untapped potential there to say like very mathematically capable biologists that don't realize that they can do both of these things. So I think that should always be something that we should be trying to do, is to bring people in. I think also on the other side of things, like although I was in a zoology department for my PhD, everyone, all but one person in that research group when I joined was either from physics, computer science, or math. There was only, I think, one biologist when I joined. So I think going from like a mathematical or physics background potentially into biology is maybe an easier transition if you've got the biological curiosity to understand those things. I mean, Carolyn has also transitioned from that background. I think Daniel, you said you started off in physics as well. Like I think making that transition in that direction is pretty easier. Not impossible to go the other way, but it's probably just a little bit easier in terms of like attracting students and training that way.
So I think I'm going to change our topic a little bit and touch on a few things that we haven't really talked about yet. So we talked about collaborations within a department and the value of having this community there, but what about more broadly outside of your department, either within your institution, locally, internationally, and how is that shaped by, like, how have those collaborations developed for you, and how is it shaped by the theoretical work that you do? Ooh, not a good sign. Does anybody in particular? Carolyn?
I can say something. So the question was sort of how international collaborations developed and how that was shaped by what we were doing. I think for me, I started going to a conference called Permafrost, which was annual and small, and it was bacterial genomics and evolution. And there were a couple of other people. I think everyone was interested in quantitative work and some modeling. Jukka Korander, who's a statistician in Finland and Norway, was one of the organizers. And it grew out of collaborations that I was already in a little bit from Imperial and Harvard. But that was really useful for me because I saw over about 8 or 10 years the research programs of these individuals develop. And so hearing their talks and reading their papers, even though they weren't in my field, and often they were quite technical in terms of the molecular genetics and the genomics, and these things are kind of got ice elements and all these things are kind of flowing past. But I got a sense of what some of the questions were that could have mathematical tools and didn't. So people would draw a phylogeny, color it in, and say, okay, you can see from the shape of this phylogeny that the process is blah, blah, blah. And I would say, well, why? Why do we know that that shape couldn't arise in a null model and a neutral model? Why do we know, how strongly do we know that? How do we think about these shapes? What are some tools that we could draw on to beyond neutral models to start understanding tree shapes? So for me, those collaborations grew out of going to those meetings and having those conversations directly. And I think it was, sometimes to do with my interests, but also meeting people at small workshops that were focused around topics and also around like bringing quantitative tools in. And there were other workshops that I think played the same role. And I think the DECO meeting in New Zealand is one. There were others that I went to in Europe at the time, which was quite accessible from London. So that was a nice thing about Imperial.
Laura?
I just want to agree that, going to conferences and workshops, particularly those that are small, where you have a real chance to interact with people and you sort of see the same faces throughout the couple days, so that people are choosing to interact with you is a good thing. I do get, the first time I got invited to speak at a biology conference, it was super scary, and I don't think I really maybe set my talk up the way I should have, but I went and did it. And, I think that's a good thing to do too, giving talks at these venues and, letting people see what you're interested in and what kinds of things you've done is also a good way to establish those relationships. So.
That was perfect.
It related to the point about to giving talks at conferences. And this is kind of like a very obvious one maybe, but know your audience is a big one if you're interdisciplinary. I think early on, maybe especially when I was going for jobs, I wasn't maybe including enough math for the mathematicians, or, was including too much math for the biologists. And so, I might give the talk on the same paper, but it would be a very different talk if it was going to at a math conference or a math department versus a bio conference or a bio department. In terms of international collaborations, I think the interdisciplinary thing has been very useful. Most of my international collaborators are biologists. And one of the advantages of being a theoretical biologist is that you potentially have the ability to collaborate much more broadly maybe than empiricists might, who maybe have to focus on one particular system or are very experienced in one particular system. Whereas, I collaborate with people who are, experts in plants and plant pathogens, and people that work on bacteria and viruses and lots of different study systems. And you could potentially do modeling for all of these different things. So I think that being a theoretical biologist does give you lots of degree of freedom potentially to collaborate widely.
Thank you guys for those answers. Thanks for responding to the questions in the chat, but I want to reflect Anastasia's question about challenges of moving internationally during your career, because I think that your responses actually mirror a lot of what we're talking about right now about differences in networking. And so would anybody like to add to their comments about how we move around internationally throughout our careers?
Well, there's a discussion in the chat right now about that. I did not appreciate the extent to which your networks are different depending on where you are and how much of a difference that makes. I thought, all right, we all go to the same conferences. And then I went to Europe and I was like, oh, no, we're not. There's different conferences. I'm seeing different people. I'm not seeing all these people from the US anymore. I'm seeing all these new people who I wasn't really aware of. Right? Like somehow I wasn't reading their papers in the journals, because the names didn't catch my eye. And then I came back and I was like, whoa, all these people forgot I existed over here. All right.
Yeah, I mean, I mentioned this in the chat of like specific issues around like, questions asked about being like a UK postdoc, and then trying to get hired in North America. When I started as my faculty job in the UK, I was on a 5-year research fellowship, which had 100% teaching buyout. So I did not have to teach at all, but that creates issues if you then want to like, either actually, if you're a UK postdoc coming to try and get faculty jobs in North America, where you'd maybe be expected to teach more, especially if you're in a math department, you might, have much more teaching experience if you're in North America than you would in the UK. But also, if you had been through that kind of like fellowship system where you hadn't done any teaching, and then there's an expectation that you would have taught a lot, your CV might not be very good. So, I decided to volunteer to teach some courses because otherwise I just wouldn't have any teaching to go alongside my research.
Carolyn?
Thanks. Yeah, I want to expand on that a little. I guess from the point of view of having been on hiring committees, I don't think the emphasis on how much people have taught beyond like, can they do it well once, is as high as maybe you thought. I do think there's a huge difference between UK and Canadian US faculty hiring, and I briefly mentioned it in the chat, but I wanted to expand on it a little bit. In the UK, my interviews were both, half an hour to give a talk, answer some questions, meet the panel. At the panel, there was someone there who did things like make sure that no one said, "So is this your last baby or are you going to have another one?" Which I was asked at a Canadian faculty interview while I was 6 months pregnant and had I had a pelvic thing, so I was slow at walking, and they accommodated that, but it was awkward, and that was the chair of the hiring committee. And, what are you going to think? Of course, they could have easily hired the guy they hired anyway, like whatever, you never know if that's a factor. But you don't, in the UK, you typically don't go around and have half an hour meetings with 14 different people per day, and coffees and dinners and lunches and all these opportunities for social faux pas or not fitting in. And people can move around in the UK a lot more easily. I think that the tenure system is maybe a little weaker, but because it's a smaller physical place, someone might have a job in Exeter and then they might have a job in a nearby city and take the train, or within London and the greater London area. Of course, people can move around quite a bit. The REF framework that Ben mentioned at that time did provide a lot of motivation for people to move around. There was a lot of shifting around, oh, we can get Ben Ashby here with his awesome record, and then he'll make us look good in our ref exercise. And that was a bit of gaming, and it had some maybe questionable effects too. But I think one good effect was to enable a lot of faculty mobility. And that meant when people were hiring, they didn't think, well, geez, we better get to know this guy in and out because we're gonna be living with this guy for 20 years. Like, we better have lunch with him and dinner with him, and everybody has to talk to him, and everybody has to like him, and it has to be so fitting in, and da-da-da. So I did really feel like you didn't have to know all the right people. You didn't have to have all the right grants. You didn't have to have been at all the conferences with all the people. It was quite open. And when I got hired at Bristol, they hired both me and another woman who was interviewed the same day. All of us on the same day. I had the call by 5 p.m. that night. That's your offer. You don't have to like 3 weeks here and then 3 weeks there and then interview here and 2-day trips to there and da-da-da. Same with Imperial. I was still on campus when I got the call for that job. I was actually having dinner before my train in another part of the campus, and I got the call saying, we'd like to offer you the job. Like, this is amazing. It's that day. So it was honestly so much more merciful and gentle than the US and Canada hiring scene. That said, they also don't pay as much. Pensions are kind of crap. So, but great science. Anyway, I wanted to expand on that.
Thank you guys. So we have a few minutes left. So I want to shift gears a little bit from getting hired to what after you get hired. So talking about resources that you have during the hiring or got during the hiring process, maybe resources you wish you had asked for, and how you have developed those resources throughout your career.
I mean, I think other people correct me if I'm wrong here, but my impression is that in terms of like money resources that you'd get, like bio is the best, physics is in between, and math is the worst. Startups are just very, very different depending on what department you're going on. Even you're going in, despite the fact that you'd be doing the same work in any of the departments.
Yeah, agreed. I think that's, and I mentioned this earlier about the perceptions of like your grant income. And I know Laura mentioned this as well about the two chairs, right? Of like having, you know, what your income is seen, but also like what you need to like run a group as a theoretical biologist is a lot lower. So I guess if you're able to apply to funders that say, you know, pure mathematicians might only have a very narrow group of funders that they could apply to, whereas you might be able to apply, you know, for example, in Canada, you might be able to apply to NSERC and CIHR. If you're in the US, you might be able to apply to NSF and NIH. So your opportunities for like who you can apply to are pretty broader, I would say, as well, if you're in theoretical biology. So it is the advantage, I think, but the disadvantage is making sure that you appeal enough to a panel that maybe might not have any theoreticians on. That kind of thing could be challenging.
So, Laura, I think you had something to say, but I'm going to just interject a request. Like, if you have thoughts for any of the panelists beyond monetary resources. So I think one of the challenges that I think about a lot is we don't ask for lab space because we're not doing lab work. But that doesn't mean that there isn't value in space or interacting with, having a space for people to interact. And so, Laura, if you have comments on monetary resources, that's great, but beyond that too.
Yeah, I mean, I was going to mention the space issue because I think for me, and it's maybe, you know, harder for me because of the joint appointment, but I've never really had access to space where I could have my students from different departments working together. So I can advise PhD students both in biology and in statistics, as well as in biostatistics, because that's a separate program. So there's 3 different PhD programs and they each get space wherever their PhD program is, and Ohio State's a really big campus. So that means that for everyone to come together, someone has to be out away from their office. And so, you know, having space that could be accessed by different kinds of trainees would be really valuable for my group. So that's sort of monetary because someone's paying for that space, but it's different than that. The other thing that, you know, early in my career, I had to really worry about computing resources. And it's sort of less an issue now because I think there's broader access to computing clusters. But for those of us who do really computationally intensive things, I mean, thinking about how the computing is going to work and whether you can have dedicated space for those working with you, those kinds of things are something to think about before you get started. The other thing is, it is true, it's hard to get a big startup package in a statistics department, in part because no one, you know, now the universities provide computers, you give you an office and they're like, go for it, you know. But I do think there are some things that you can think about, like, you know, having an RA position, a graduate student who does research with you that you pay, you know, and maybe not having that start your first year as a faculty member, but having it start your 3rd year when your research is really starting to take off. So, you know, thinking about being able to fund student research is all, and again, it's monetary, but it's not, you know, just money coming into me. It's, you know, how can I fund someone to help get my research program moving. So I think those are some really tangible things. The other thing I could mention is, you know, funding for travel to conferences and things at the beginning before you get your grants up and running and have tons of travel funding is also useful.
Wonderful, thank you for that. So we have hit the 11 o'clock Mountain Time mark, but I really am grateful for all of your guys' answers. And if there's any thing left you would like to add, I would really like that.
Thanks for letting us rant. That was super fun.
Yeah, thank you. And thanks to Burst for organizing this hybrid program. I'm excited about the format and of course the content. So, and thanks Ailene for organizing. It's been great.
Thank you.
Looking
So
forward
if
to
you
the rest of
enjoyed
the program.
today's discussion, there is a parallel one coming up in the future that Maria will lead on the corresponding biology side. And with that, we will see you in between Darwin's birthday and Valentine's Day on February 13th, which I think is very appropriate. And so see you in February.